Alright, this is the video lesson for 3-5 ratios and proportions. First thing we need to look at is the definition of what a ratio is. And a ratio is a comparison of two numbers by division. Again, a comparison of two numbers by division. Some examples of this would be 3 to 4. Now there are multiple ways to write 3 to 4, the first being 3 to 4, the second being 3 with the colon sign 4, and the last being what we see in mathematics the most, 3 over 4, or the fraction 3 to 4. And for our lesson on ratios and proportions, we will be pretty much solely dealing with the fraction form 3 to 4. So our next definition is what a proportion is. And a proportion is an equation stating that two ratios are equal. So just simply an equation showing two ratios are equal. Another way to think of that is an equation showing two fractions that are equal. First example of that would be 2/3 is equal to 6/9. And again, we know this is true because to change the 2 into a 6, you would multiply by 3. Same by changing the 3 into a 9. You're multiplying pretty much the numerator and denominator by 3. So because of this, we realize that these two fractions are equal. Means these two fractions do form a proportion. Another example of this would be 24/30 is equal to 4/5. And again, we should all know that this is true because it's just like reducing fractions. To reduce 24/30, I am going to divide both the numerator by 6 and the denominator by 6. So 24 divided by 6 is 4, 30 divided by 6 is 5. So again, this shows two equal ratios. So that means these two equations are what we call a proportion. Again, a proportion is an equation stating that two ratios are equal. Alright, what you'll see down here next in examples 3, 4, and 5, they want to have you determine whether each pair of ratios forms a proportion. So in other words, for number 3 here, they're asking, does 1.5 over 2, is that equal to 6 over 8? Now, the problem here is that I don't know exactly what to multiply 1.5 by to make a 6. You know, and obviously this will get more difficult, but maybe you do, maybe you don't. Let's just pretend I don't know what I would have to multiply 1.5 by to make 6, so I don't know if these two fractions are equal or not just by looking at them, which that's fine. I'm going to teach you a new way to decide whether two fractions are equal, and that is by using cross multiplication. Okay? So cross multiplication is going to determine whether these two fractions or whether these two ratios do form a proportion, or whether these two fractions are equal. So what you do is you multiply the diagonally. You're going to take 1.5 and multiply it by 8. And at the same time, you're going to take 6 and multiply it by 2. And in this case, we get 12 is equal to 12. Again, I'm checking to see if the cross products are equivalent. 1.5 times 8 is 12, and 2 times 6 is 12, so 12 equals 12 is a true statement, which means yes, these do form a proportion. So again, if you get a true statement, yes, they do form a proportion. So 1.5 over 2 is equal to 6 over 8. So now looking at number 4 here, we're going to do the same thing. We're going to ask ourselves, is 24 times 50 equal to 18 times 75? And in this case, you can see that no, they're not. 24 times 50 is 1,200, and 18 times 75 is 1,350. This is not a true statement, this is a false statement. 1200 does not equal 1350, so that is false, meaning no, these two fractions are not equal, or these two ratios do not form a proportion. So again, same thing with number 5. We're just going to simply use our cross products. 0.2 times 0.45 and 0.1 times 0.09. And yes, 0.2 times 0.445 is 0.09, and 0.1 times 0.9 is 0.09. Those two are equal. So yes, these two fractions do form a proportion. So that's again using cross multiplication to just simply see if the two ratios are equal. Do the two ratios form a proportion? And they do if the two cross products are equal. Alright, so for our last 4 examples here, we're actually going to solve proportions. And in this case, you're going to look and you're going to say, okay, what number can I plug in for the variable to determine or to make the first fraction equal to the second fraction, or vice versa? And again, we're dealing with ratios and proportions here. So in other words, on number 6, I'm asking myself, 4 over 6 is going to be equal to 8 over what? Now, again, on this very, very simple problem, some of you are probably looking here and saying, hey, I can just take 4 times 2 and get 8. So that means I would have to take 6 times 2 and get 12. So x must equal 12. And if you understand that, very good. That is very good. That is what is going to happen here. But again, these problems will get more difficult. So we're going to practice this with cross products or with cross multiplication. So let's do our cross multiplication again here. We are going to take 6 times 8, which gives us 48. And that's going to equal 4 times x, which gives us 4x, just like we did in the previous 3 problems. In this case, we have an equation set up now. 48 equals 4x, and we're going to solve this equation like we would any other equations in algebra. We're going to get x all by itself by dividing both sides by 4. So for this problem, as we've already seen, 12 is what x is, so x is equal to 12, meaning that plugging 12 in for x creates a proportion here. It creates a ratio equal to another ratio, or a fraction equal to another fraction. So 4/6 is equal to 8/12. Alright, so like I said, in number 7, this gets a little bit more difficult because I now cannot tell what I would do to 33 to turn it into a 15. So because I can't really tell that in my head, or I don't know what 33 divided by what makes 15, I do have to use my cross multiplication skills here. So cross multiply y times 15 is 15y, and 33 times 45 is 1,485. Again, I'm going to solve by dividing both sides by 15, and I find out that y needs to be 99 to make these two equal fractions, or for these two ratios to form a proportion. 33 over 99 is equivalent to 15 over 45. Alright, now 8 and 9 get a little more interesting. One thing about 8, you'll notice in the first numerator you have 2 pieces to it. You have a 2 plus a w. When you cross multiply, in this case, you will have to distribute. So when I take 9 times the quantity of 2w, I take 9 times 2, which gives me 18, and I take 9 times w, which gives me 9w. So I get 18 plus 9w in this case. My other cross product is the same. I'm going to take 6 times 12. That's 72. Now you'll notice that we have a 2-step equation to solve here. Trying to solve for w, I will subtract 18 on both sides. 72 minus 18 is 54, and the 9w simply comes down. and then I divide both sides by 9, leaving me with 6 equals W, or again, W needs to equal 6. Now, think about this. If you would plug 6 back into W, you would have 2 plus 6, which is 8. So you're saying that 8/6 is equal to 12/9. And you could reduce both those fractions and realize that that is, yes, indeed a true statement. So W needs to be 6 in that case to make that a proportion. All right, last problem here. Again, I have a distributive property that is going to have to happen here with the 3 plus y times my 8. I'm going to start here with 4 times negative y, which is negative 4y, and then 8 times 3 plus y should give me 24 plus 8y. Again, I have a multiple step equation here that needs solved. You have variables on both sides, so the first thing I'm going to want to do is get my variables together. I'm going to do that by subtracting 8y on both sides. 4y minus 8y is negative 12y. So now I have negative 12y equals 24. And my last step here will be to divide both sides by negative 12, giving me a final answer of y is equal to negative 2. So that is how proportions are solved. Now, I do want to mention that we will be doing story problems in this case. And when we do story problems, which we'll be doing some examples in class, obviously, what you need to make sure you do is when you set up your ratio, make sure that you have the same units in the numerator as you do in the denominator. So for instance, if you're comparing miles per gallon, and I'm showing this up here in the right corner of the screen, if I'm comparing miles to gallon, make sure in your next comparison of quantities you also have miles over gallons. Don't ever have these flip-flopped. And this will make a little more sense when we start setting up proportions with story problems. I did not have one of those as an example, but we will definitely be doing those in class. So just keep that in mind. All right, that is all for lesson 3-5.